All right. Welcome to Midweek with Max. We have a smaller group than usual this week due to some folks traveling and being out. But thanks for joining us. This is Rick, joined by Joshua, and of course our co-founder Max Sanchez. So let's turn it over to Max.
All right, cool. Thanks everyone for joining us for another week of Midweek with Max. A couple updates on the engineering side. Pretty much same as last week, just more progress on all the open work streams. I've been doing some differential testing and fuzzing with OpReth, both the TVC and the oxygen version against OpGeth as the sort of golden sample. So we've been finding some small edge cases of things that we need to fix up in there. So that's been useful. On the formerly Minerfy, now fast track. I don't know why I always mess up with that. Fast track side, we've been just continuing to do some more hardening and improvements there. For the ZK marketplace, ZK miner, we've been doing some cleanup and getting builds for the ZK miner, working on different platforms and different versions of GPU drivers. So kind of boring housekeeping stuff, but stuff that we need to get done to do a production, not production mainnet, but a public release of that for beta testing. So that should be coming along soon. Hopefully we'll have more info on that next week. Other than that, we've been, so the VE Hemi rewards are coming soon, I promise. We've had some delays because we're looking at reworking the VE Hemi system a bit. And actually, maybe a little bit later in this video, I'll do a quick demo of a UI design. It's not finalized, and we'll talk about some things that may or may not change in it. But basically, a redesign of the VE Hemi system and some upcoming changes that we want to make to the way that rewards operate in more of a forward epoch-based fashion. So we'll discuss those as well, and maybe look through that UI demo. And let's see, aside from that, I think those are all the major items. We've done some other improvements on Dave that we've been working on and testing on our infrastructure. That's kind of a boring back-end note, but if you are managing nodes for EVM network, especially L2s, Dave is open source and it's a good, useful tool for managing deployments. So if that's something that you do either for Hemi nodes or just in general, it's definitely worth checking out. And I think with that, that's pretty much everything on the engineering side. And for the usual ones, I do not have any updates on VBK at the moment, but as soon as we have them, we will share them, and it is still coming. For the new pop payout algorithm, also coming soon. We just got the OpGeth hardening release. We got it merged in a few weeks ago. We've gotten it into Hemi node as a PR that's about to get merged in. So once that's released and pushed out, we should finally be able to get the updated pop payout stuff out. And I think that's pretty much it for the usual. So I'll turn it over to Rick and we can go through questions.
All right. Alex asks, how much fees were generated since the last VE Hemi distribution?
I don't have the exact number, but I want to say roughly 8 Ethereum. Might be 7.5 or 8.5, but somewhere around 8 Ethereum.
All right. Will there be a Hemi season 2?
Not in the same way that we did season 1. So as we've talked about in previous weeks, basically the original testnet season and then mainnet season 1, those were prior to there being a token available, and so everything had to be done with a point system. And now that we've had a token available for coming up on a year now, we've moved away from doing the points-based system to doing more just direct liquid incentives, which is better for most people using the system because there's not some unknown future conversion of points into tokens. There's not some unknown how many points you represent versus how many points in total are being generated and how many new tasks could get added with different points in the future as part of the same season that could potentially dilute you. So we've mostly moved to liquid incentives. So we have a bunch of incentive campaigns on Merkle. And then also we've been doing one-off. I don't think we have any active now, but in the past we've done one-off campaigns with specific protocols where, say, a new protocol launches, they have their own built-in incentive mechanism, and maybe we subsidize, if it's a DEX, we subsidize yield or something like that on some of the pairs like Hemi BTC, ETH, stablecoins, things like that. But right now, I think all of the active incentives are the Merkle campaigns, and some of those also coincide with some incentives on Curve with Stake DAO, which I think does not go through Merkle. So it'd be Merkle incentives plus Stake DAO incentives for liquidity. We are going to be, we've been talking about, we were originally trying to use Guild. They didn't work out for what we were trying to do. So we've been switching over to another platform. And that will have more of like a kind of a point system in a way, but it won't be the same as, the old system with Absinthe and collecting a bunch of points and then these, long multi-month seasons that eventually close and convert over. With some claim process, it'll be more dynamic, but we can include things that aren't directly economic activities. So for all of the mainnet incentives, those have been around things that are, $1 of liquidity equals that, 3 cents of reward over this period of time or whatever. Whereas things that aren't necessarily economically centered, or it's the kind of thing where we benefit more from having a lot of people do a small amount of something rather than one person doing a large amount of that same thing. Those will be going through the new platform Zeely that we're working on. And so that's still coming along, but it's kind of a hybrid in between the old Absinthe system and the current liquid incentives through platforms like Merkle. So no, we won't be calling it season 2. It won't behave like season 1, but just shift it out. But it will have some of those mechanics that are a little less tied directly to underlying economics of certain activities.
All right. Hexugian asks, what is the timeline for moving from a centralized sequencer to a fully decentralized proof of stake model?
As far as timelines, it's going to be after HBitVM, so more than likely sometime early, I'd say Q1 to Q2 of next year. We want to do it correctly, and there's a lot of stuff that has to be designed and tested to have a truly decentralized proof of stake system. A lot of other networks have a version. I don't want to get too much into comparing proof of stake approaches with different L2s, but the way that we want to do it is using essentially a clone of Ethereum proof of stake, which just because it's a clone doesn't mean it's easy. There's a lot of things you have to adapt to an L2 environment, but from a security and economics and kind of protocol behavioral perspective, it would be essentially the same as Ethereum's current proof of stake model. And the reason we're doing that is because it lets us have a lot more decentralization. So most of the other proof of stake approaches are limited. There's 2 major problems. One, they're limited to a small number of participants in the system. So maybe that's 100, maybe that's 1,000, but it's not potentially 100,000 at some point in the future. Whereas Ethereum's proof of stake, the way that it's built, it can handle and scale out to, within reason, basically an unlimited number of validators on the network. That lets us let smaller participants participate with less stake, because we don't have to have this system where you have to have so much Hemi that only 100 people could put together enough Hemi tokens to be a sequencer. So it makes it easier for people with smaller amounts of tokens to participate. Obviously, more decentralization of the number and ultimate ownership or control of the sequencers is important. But the other thing is Ethereum proof of stake gives us benefits on the security side, which makes sense, especially in the context of proof of proof and what we're doing with HBitVM. And so some of the other approaches to proof of stake, they prioritize safety over liveness, which can make sense in certain scenarios. It's not always guaranteed to be the incorrect choice for proof of stake design. But given that we have Bitcoin and proof of proof, and we can use that as a version of very high security finality that kind of bookends the very last stage of consensus, we can prioritize liveness for the intermediate block agreement protocol, or the proof of stake side of the consensus protocol. And we can use that to basically make the network resilient in the event that there were to be some very large consensus outage or very large consensus attack against the native proof of stake, then people could just fall back to the Bitcoin finality for waiting for something to be truly confirmed and known as part of the network that can't be reorged off the network. But it gives us the flexibility for the network to naturally heal and recover. So one of the narratives you'll hear in the Ethereum space is Ethereum proof of stake was made to survive World War III. And maybe that's a little bit extreme, but the idea is with, the way that the global internet infrastructure works and the way that, you have various, depending on how the consensus protocol evolves and like who's actively staking, you can end up with even, though you have a lot of people who have individual token positions that are earning from a staking system, a lot of people centralize around a staking provider. And so there's always the chance that, somebody runs some giant staking service and gets a ton of people to use it, and then they either get hacked or they become malicious and they could attack the protocol. And so because we have proof of proof and we can use that for Bitcoin finality, we can prioritize liveness, which means that even in that event, the network naturally fractures in a certain way, finds a way to recover, has inactivity leaks for either misbehaving or unavailable stake in the network or validators with stake in the network. And so for those two reasons, we're choosing Ethereum proof of stake, which is more complicated, but it gives us more decentralization and lets us choose that liveness over quote unquote safety, which we solve the safety part of that by backfilling that in with Bitcoin finality rather than relying on just the native consensus protocol for the safety assumptions. So short answer, probably Q1 to Q2 of next year, it will be post HBitVM, post ZK settlement to Ethereum, and then HBitVM is obviously ZK settlement to Bitcoin. That's the next major feature on the roadmap after those two items.
All right. Let's see. When will Pop Points tokens be converted to Hemi tokens?
I think we already answered that one. I'll answer it again just in case we didn't. For some reason, I think we did, though. So we
I
did
think
just
we
get.
did. Sorry about that.
Okay, no worries.
All right.
But
Yeah,
short answer
my
is
bad.
it is coming soon. I know a lot of things are coming soon, but we did get the hardening release for opgeth out, and that's what we're waiting on to rebase all of the working branch of the new pop payouts v2 stuff on top of.
All right. Let's see. Can we know more about Hemi's roadmap and any upcoming partnerships?
So technical roadmap for sure. The main items, so we have the fast track, formerly MinerFi system, which is the easy Bitcoin on and off boarding system that's going to wrap around the HBitVM tunnel. So that's been largely feature complete, but doing bug fixes, and it needs to go through a formal audit before we launch that. Then we have the entire opreth conversion and the introduction of Oxygen, which is our ZK capable, ZK optimized Bitcoin indexer. That's going to allow the entire network, the entire Hemi network, to be ZK proven. That unlocks ZK settlement to Ethereum and HBitVM, which is essentially ZK settlement to Bitcoin with a one of n trust assumption. And if you want it to be truly trustless, you can be one of those n very easily and participate in covenant emulation. After that, the next big thing is decentralizing the sequencer. As part of the entire ZK proving thing, as I don't want to call it a side project at this point, but as a ancillary supporting project. It's not a main focus, but it's something that we built because it makes our ZK proving more resilient, and we've built it in a way that it's generic enough that other people can benefit from it, whether they're building DApps on the Hemi network, whether they're building L3s on Hemi, whether they're building L2s that have nothing to do with Hemi and just need ZK proving as a service. So we do have a ZK proving marketplace that we've developed that needs to go through audit, but it's feature complete, and a ZK miner that attaches to that anyone can run on consumer hardware. I won't belabor the ZK market too much, but some of the things that make it cool, I'll try to keep this to bullet points. Most other ZK proving markets are confined to a single ZK VM proving system, although that is changing a little bit. And B, they are defined, the jobs themselves in the marketplace are defined by providing the witness instead of defined by the validity of a certain statement that they prove. And so we're flipping around. The reason you want the latter is because, or the reason you want to change the latter is because it's very hard to compose in DeFi, have a smart contract, for example, pay for a ZK proof of itself, because that smart contract can't introspect, deep into the Ethereum state tree and get, intermediate nodes in the state tree and serialize a witness. Even if it was possible, it'd be way too gas intensive to be practical. And in reality, even though Ethereum is very good at self-introspecting, it can't introspect sort of behind the scenes details of its state tree construction, things like that. And so it's very hard for a DApp to automatically coordinate its own ZK proofs of itself, whether it's you wrote a central limit order book that has some off-chain order matching system that's too heavy to run on-chain, so you're ZK proving it. The protocol itself can't easily incentivize ZK proofs, so you need the team or somebody behind the project running like a centralized daemon and have that submitting jobs to the marketplace, which is a central point of failure. If they stop doing that, ZK proofs stop being proven by the protocol because the jobs don't come in. But also it makes it, from a team managing a project perspective, it's more infrastructure to manage, it's more things to monitor. And so with this marketplace construction, we built it this way because we wanted the Hemi network, the protocol itself, to be able to automatically incentivize all of the ZK proofs that it needs for its own settlement to Ethereum, settlement to Bitcoin for unwinding HBIT VM vaults for withdrawals. And the only way to do that is to build a marketplace where you define the proofs optionally based on witness serialization if you want to use the old model. But with the new model, you can define them by outcome and then leave it up to the market in theory. In reality, you have, plugins or ways to basically tell an instance of the ZK miner how to understand different proof requests and go and fetch out and serialize everything they need themselves from like public RPC data sources. But it allows that composability in DeFi where we don't have to run a daemon that holds, tokens on this person's ZK prover network and that one for risk 0 and SP1 and OpenVM, and then request the jobs by serializing all this data and pinning it to IPFS, yada, yada, yada. Instead, we can just have the protocol talk to a marketplace that supports any ZK VM proving system. Anyone can add in support for new proving systems dynamically. And the protocol can just, as long as it does Hemi tokens to spend on submitting jobs to its own ZK prover marketplace, it can do that without needing to do the witness serialization. So there's no extra infrastructure. It's entirely, as long as the chain is running, the protocol can dynamically request ZK proofs of itself and interact with that marketplace. So that's a adjunct item that I'm excited about from a tech perspective, and I think is cool as a building block, especially as we scale out with chain builder and things like that. It's not a, major unlock roadmap item. It's more of a nice to have, and it's a cool way to get more into the cross-chain interoperability space and work with other protocols that are doing interesting things for that. So the current list that I talked about was Fast Track, formerly MinerFi, HBIT VM, and ZK provability in general with ZK settlement to Ethereum as an adjunct at ZK Prover Marketplace. After that, as we mentioned earlier, the next major item on the roadmap will be the decentralized sequencer. And then after that, it's going to be decentralizing some other components. So decentralized proposer and batcher, which we collectively call the publisher. And also after that will be most of the chain builder roadmap of first sort of a reference implementation L3 that you can spin up on the Hemi network, and then expanding those reference implementations to have more flexibility for configuring them for different trade-offs between decentralization, speed, security, and cost. And all of those will ultimately inherit Bitcoin finality through Hemi as a sort of security aggregation layer. And then the final piece, there's always more stuff you could add, but the final planned piece for Chain Builder is a shared sequencing, shared DA system that basically makes it super easy to spin up L3s, have them speak a common language for interoperability purposes that is not forced on them in a, the style we've seen on chains like Cosmos, but is offered as a choice that chains can make if they want a deeper level of more atomic interoperability with other L3s, and Hemi as an L2 itself in the ecosystem. And then post that, or in addition to that, sort of macro major roadmaps item, we're going to have some improvements to HVMs, adding some new precompiles that do some more interesting things, including ordinals, things that let you dive deeper into, say, historical transaction fee data, stuff like that. We're also, as part of or in support of the decentralized sequencer, HBitVM, all of that, we are going to be upgrading the VE Hemi system to act as an economic security system. And so basically, you can take your VE Hemi position that is, currently just Hemi staked, that lets you, vote in governance and collect some incentives. That will be transformed into a system where you can optionally restake that position into different protocols and choose to, say, participate in decentralized sequencing with your VE Hemi position or an HBitVM covenant emulation, or if it's a large enough position, HBitVM, being an HBitVM vault operator, being a participant in the threshold signature scheme system for the FastBridge technology, being one of the decentralized publishers and batchers once we decentralize the proposer role, and then at some point participating in running the infrastructure for Chain Builder, that shared sequencing, shared DA system. And then we can also use it for other smaller offshoots, like, for example, the ZK Proving Marketplace needs sort of a consortium. It doesn't need this, but it works best when you have a consortium of users who are staked and basically blindly attest to, blindly as in they're blinded from each other's decisions, attest to the compute complexity of jobs, so that then that can be used as an on-chain compute complexity pricing oracle per target ZK VM. And there's other stuff I'm sure that will come up that will also be hooked into that system. Initially, it'll just be used for sort of the core protocol pieces, but eventually we will open that system up so it can be used as economic security for anyone else who's building, whether it's on Hemi or anywhere else. You could use that as a economic security system as long as you can define slashing conditions on-chain programmatically, which is sort of the base case requirement for all automated economic security systems.
All right. Let's see. What do we? Oh, okay. Here's a weird one. Will there be any news? Or how hard is the team working?
There will be news.
What?
There has been news.
There
There's
has
things
been
going
news for
on.
23 minutes.
How hard is the team working? Harder than we should be. We've got a lot of things in the pipeline. I think everyone's working, I would say at a minimum, probably 60 to 80 hours a week, depending on the week and the person. So there's a lot going on behind the scenes. These are hard things to build.
Right. I'm just sorry. I'm just scrolling, looking for further questions. Uh, do you think on-chain election is the best use case for blockchain tech?
I wouldn't say best. I think it's a very compelling use case. Um, the If you're talking about things like actual real life government elections, I think there's still some hurdles to adoption, and not just on people understanding it and a government choosing to use it, but there are still some hurdles on the tech side that we're getting closer to figuring out, and there's constructions that you could come up with that would preserve. So the two properties you want out of blockchain elections, and there's other things you could add, but the two core properties, from my opinion, is one, you want to be able to prove that a certain person only voted once and that their vote was correctly counted. And B, you want to provide some level of privacy. There should not be a public ledger of every single person's voting history. And privacy is a spectrum, so that can go anywhere from, only the government can decrypt it, all the way down to even the government can't see who voted for who, but somehow with some cryptographic magic, we can still determine who won the election and prove that everyone who voted was authorized to vote in the election without knowing any one specific person's vote in that system. And so that's sort of that ultimate version of privacy is sort of the holy grail. And again, there's a technical component, obviously, to making that work. There's also a governmental component of them being able to, you know, trust the underlying technology, but also give up sort of control of elections to a system that, they may have vetted the math and understand the math side of it, but that, is sort of blind. And in the event that there is some suspected bug in it, there's really no way to audit it. This isn't a perfect example, but if you take like the recent issue with Zcash, one of the issues, so if you were to build that kind of election system, you would do it with, depending again on the privacy level and whatnot, you could do it with a mix of ZK proofs and fully homomorphic encryption. And so you could basically have a system where everyone can submit ZK proofs of their vote, basically a ZK proof that proves that their identity, who was approved to vote in the system, voted for a certain candidate and did not vote for any other candidate, or just that they voted. And then that could, kind of like you have the, not quite a nullifier, but basically you have a way with, something like Zcash to prove that you are spending coins that haven't been spent yet. You can use that same mechanic to prove that I'm casting a vote in an election that I've not casted a vote for that election yet. So you can use that same mechanic. You can use FHE to sum up the total. And so you could have basically a ZK proof that your vote is unique that outputs an encrypted payload, which is in fact your vote. And that could be go into an FHE system, and then only the government would be able to decrypt the final votes at the end. But even the decrypted votes could not be correlated with the original user because that's been basically blinded by a layer of ZK. And if you look, what I was going to say a minute ago, sorry, I'm not on a ton of sleep, is if you look at like what happened with Zcash and sort of where these kind of systems could theoretically fall apart if not implemented correctly, if there's, a bug that somebody missed in one of the circuits that allowed something to be under constraint or whatnot, is when you look at the Zcash case, somebody could have theoretically abused that bug in Zcash and printed brand new tokens out of thin air because basically the system wasn't properly enforcing conservation of tokens. And you can't go back and really audit that because since everything's in ZK, it's not like Bitcoin where you could go and see, okay, hey, that's the Coinbase transaction that created 10,000 Bitcoin out of thin air and shouldn't have been allowed to exist. Okay, that was the issue, that was the bug, and we know if it was exploited and how much it was exploited for, and then the network can collectively agree to freeze those coins or leave them as part of the protocol or whatever. But it's at least a known bounded problem of, say there was a bug in the Coinbase transaction validation on Bitcoin, which by the way there was very, very long ago, and I think actually Jeff Garzik was the guy who discovered it. But anyway, for a clear text sort of network like Bitcoin, when you find a bug like that, you can go back and look through the chain and see if it's ever been exploited. And then the community can collectively decide what they want to do about it if it has been exploited and the total blast radius. With ZK, or at least ZK in the context of these sorts of privacy designs, you don't have that same level of auditability, or really you don't have any auditability, quite frankly, or, you can maybe look at some things heuristically and that's about it. And that's sort of a second order derivative of, you can look at, was there a giant glut of tokens that's very suspicious at some point on exchanges or something like that? Those are the only heuristics you really have to look at. And so if you build that kind of a voting system, you have the same issue where, if say 2 years from now, somebody found a Zcash-like bug in the voting system construction, well, we couldn't just go back and do a recount and make sure the vote was actually legitimate. There's ways you could potentially build a system that could balance for that. So you could have maybe some sort of a system where, users have to, if there is a recount, users have to revote in a certain way that can be proven to line up with the original vote. And if they don't submit a proof within a certain window, their vote's not counted in the recount. But again, that's, not really a great solution to the problem. It involves running a whole new election, having people do a bunch of complex stuff and having kept, secret data safe somehow for 2 years that they're still able to get to and then reuse in this recounting process. And, good luck coordinating a few 100 million people in a country to, keep very careful, control over some secret blob of data for 2 years in the event that there may have to be a recount in the future. So it's a really cool technology. Obviously, at some point, with using it in the blockchain industry where there's financial incentive to find exploits in it. Now with ZKVMs, they make it a lot easier to implement systems that you can reason about, and that somebody doesn't have to be an expert in ZK circuit construction to audit. They just have to be an expert in, say, whatever your target language is, like Rust, and how your protocol is supposed to work, and basic cryptographic primitives, and the sort of security bounds of the ZKVM that you're using, and have some knowledge of what flakes in that ZKVM you have to be aware of, like whether a certain precompile that's doing some elliptic curve point operation is checking that the elliptic curve point is actually a point on the right curve before it does the pairing, whether that's something you have to check upstream, right? So there's nuances like that you have to understand based on the ZKVM system, but it makes it a lot easier for that sort of a system, maybe not quite as computationally efficiently, but for voting that doesn't really matter because it's small computations, and you can, once you have the ZK proof, you can aggregate those together, and there's things you can do that are pretty efficient. So with ZKVMs, you can implement your voting system across multiple different ZKVMs, kind of like we're doing for Hemi, where we're using multiple ZK proving frameworks, so that if there's a bug, say, an under-constrained opcode in one of them or something, you can manipulate I'm just picking a random one, but the RISC-0 execution trace, but you can't manipulate the SP1 or OpenVM execution traces. And so if you have a 2 of 3 or 3 of 3 for voting, consortium of required proofs of validity, then a bug in a single ZKVM implementation would not affect the solvency of the system, or for voting, the security of the system, or soundness of the system. And then for the actual, if you're running the same code on the same 3 ZKVMs and your code itself is broken, well, then that's a single point of failure, but that's a much easier surface to reason and audit about versus custom circuits that you wrote for some complex voting scheme. So short answer, I think it's a really cool idea. I think fundamentally the technology is available to build a very robust, privacy-centric, functional and sound voting system. But the way in which you design it, you have to be very careful in how you design it. And just as a case study, something like Zcash, you'd be using a similar technology to what Zcash uses for privacy, for making sure that coins aren't double spent, but instead it's the double voter problem, right? And so if there were to be an issue found in that the election results can be retrusted and a recount is functionally impossible, given the practicalities of, tens, hundreds of millions of people voting, and to be able to do a recount fairly, not have people, change their vote when the recount's done, they would have to preserve some private information for potentially years, keep access to it, and that's just a impractical thing for a voting system. You also do have the issue of voter registration. So somehow some authority has to say this cryptographic identity is allowed to vote in the system. So the goal of a blockchain voting system is, not to be fully decentralized, because there's no way you could ever truly have, there's no way I can prove I'm a citizen of the US or France or wherever without there being some authority who decides who is and is not a citizen of that country. And so, ultimately, it's kind of that last mile problem in crypto of, say you're interacting with RWAs. Well, at some point, say it's a real estate RWA, there's still a house sitting somewhere physically in the real world. And anything that the system learns about that has to be relayed by some trusted party. Could you come up with, in very specific scenarios, some very complicated ZK proving scheme based on, say, an open weights AI model for, analyzing live video of the property to determine value? Theoretically, yes. There's tons of problems with that approach of, is the AI going to be able to look inside the circuit breaker and see that, all of the wiring is done correctly? Probably not. Well, okay, what if it just becomes this problem of, ultimately there's some human trust for these real world interactions. Blockchain voting is the same, where you still need to say, the government needs to say, hey, these are the people who can vote, or at least the cryptographic identities that we have verified align with unique individuals who are qualified to vote in the election. And then from that point forward, other than the risk of a bug in the system, something like that, there is technology available to make the entire voting process and vote counting process private for everyone in the system, including your vote being private from the person who's doing the vote counting, which is the government. And then everyone can verify based on on-chain data, assuming that they trust the original registration process, and that's its own problem, that the election was conducted correctly, and that the end result of that election truly was this candidate winning with this number of votes, without anyone in the system knowing what anyone else voted for, including the party who authorized the voters in the first place. So it's a cool use case. I think we will see in some limited fashion some governments adopt it, but also probably goes without saying, a lot of governments like to be able to keep control of their voting system and keep some of it private for various reasons. And so private as in they can see it, but nobody else can. So it's a cool idea. The tech's there, other than that last mile problem that fundamentally you can't connect a blockchain to the real world without some sort of trusted oracle or system. Now, if you're talking about blockchain voting for, say purely on-chain things like people participating in a decentralized, a DAO or something like that, and being able to do, private secure voting for that system and control of on-chain assets, that can be done end-to-end securely. Again, minus there being a bug, obviously, in the system, but that can be done end-to-end securely because the user's identities are based on, say, like their ownership of a portion of the DAO or something about their on-chain activity that can be cryptographically proven. And then you don't have that last mile registration process you have for real world government elections. I went off on quite the tangent on that one, so we'll wrap that up there.
That's okay. That's okay. We know it's an exciting topic for you, so
It touches ZK
let's see.
and government and regulations. What could be better?
Exactly. All right. Are there any new hippos in progress?
Yes, there's one for the upcoming the Hemi distribution. There's one for the Pop Payouts V2, and then there's one for uh, we haven't started drafting yet, but there will be one for the OpGeth to OpReth transition, and then after that, another one for the network upgrade that forces the transition from OpReth with TBC to OpReth with Oxygen that enables ZK proving. So next one you'll see will be VE Hemi, then Pop Payouts, probably then OpReth transition launching the OpReth version of the daemon and deprecating support for OpGeth, and then once everyone's moved over to OpReth, then a separate activation date and corresponding hippo for deprecating OpReth with TBC in favor of OpReth with Oxygen, and some changes to the protocol that are the reason we require the deprecation, because to be a valid full node, you'll need to validate certain statements about Oxygen state as part of the block validation process.
All right. Alpha asks, when Hemi Arcade merch? That'll be tomorrow or the next day, and we'll get threads with all the winners set up today or tomorrow. So very soon, in other words. But yeah, no, literally, it will be this week. Um, User asks, what is Hemilabs/FPMM? The repository appears entirely vibe coded and contains security vulnerabilities that I've reported through BugCrowd. What is Hemi's internal AI policy?
FPMM was just a experimental thing. It's not used in production. It's not audited. It's not. It's basically just a tech demo of some ideas for prediction markets we were looking at, I think, quite a long time ago too. So it's as with everything, if you find a security issue in a repo, even if it's not being used in production, we appreciate the reports for it. But it's not something that we're planning on launching, or if we do, it's going to need a serious overhaul and full audits before it's launched. And it's not, actively. There may be a testnet deployment somewhere we play around with, but there's no active money being handled by it, and it wasn't meant to be a production grade, production ready deployment. It's just a open source experiment that we did quite a while ago.
All right. What do you think about code libraries? moving to AI copy-paste prompts. Will AI entirely deprecate the process of writing code?
I assume this question's for like the installation instructions where they, instead of saying like, here's the three commands you need to, you know, clone our repo and compile it and install it and configure it. Instead, just give Claude this agentic prompt and it'll figure it out for you. Uh, I mean, I think it's a little silly. Quite frankly, there's reasons that you have, like, things that are deterministic should be deterministic. And, compiling a code library or, installing it to your, you know, binaries directory or configuring permissions right, or, you're setting up a database and there's some initial configuration or initialization you need to do. That's all deterministic stuff. And so handing that off to an AI to say, I think it's a support nightmare if you have a bunch of users who you're supporting because, you know, not every user has the same AI. Not every user is going to be using the same model, even with the same, whether it's an Anthropic subscription or OpenAI or Grok or whatever, they may not be using the same model. The provider may be switching models out under the hood. LLMs are inherently run in a non-deterministic fashion. They can be run deterministically. They're, at the end of the day, they are mathematical computations. You have a certain set of known weights and you're running inference over those with known inputs, but there's so many things that go into how LLMs operate that they're intentionally non-deterministic because the labs will, and I'm not an expert in AI by any means, but there's things like temperature which make the AI even so. At the end of the day, an LLM is basically a really, really, really fancy next word predictor. And so what it does is it has all of this complex machinery, all of these weights. It runs inference with certain input activations with a certain context window. And then at the end, it gets essentially probabilities for what it wants, or weights rather, for what it wants to put out as the next word. And so, if you had the sentence, the dog ate my, it might have, the next options are dinner, homework, and airplane. And airplane is going to be rated really low because that's, your dog probably didn't eat your airplane. It is theoretically possible. There may be, some bastardized example in the training data that had that or something like that. But, it'll have sort of this sort ranked list of next words that it wants to output. And so the dog ate my, and then you have, homework is number one because that's a common saying. Dinner is, weighted, maybe homework's weighted, 90 points and dinner's weighted 70 points and airplanes weighted, 1 point or something. And then it'll run a random number generator, a PRNG, to go and decide, okay, based on that weighting allocation, which next word in the AI do I choose? And so you could run an AI deterministically where you say, always just pick the top option, but that's going to make AI, if you're just using it conversationally, very boring because every time it says the dog ate my, it will say homework guaranteed. But also for AIs, especially now that have like reasoning models where the AI sort of, for lack of a better term, talks to itself, that randomness allows it to explore different patterns of thought, if you want to call it thought, where, the reasoning model is not going to get stuck in a loop where you have, one output that's fed back into the system. Say the output is, oh no, the user isn't able to access this file. Let me think about this, blah, 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 blah. Then it gets down and says, I know, and the only, since it's running with, no temperature setting, it's going to always choose the same solution to that problem, try it and then fail. Whereas if you have temperature, the reasoning model is going to, with very high probability, choose what it thinks are the best options, but also sometimes choose lesser options. And then sometimes that can be the unlock that you need for the AI to be able to overcome a problem and then keep going. So the reason I bring all that up is AI is not only non-deterministic, it's intentionally non-deterministic for good reasons in most cases. And again, you could have determinism with a certain temperature setting. And this is actually, by the way, the same approach that Anthropic is using for their watermarking. So we talked about this a few weeks ago, and I wasn't as caught up on it as I am now. The way that they're doing the watermarking in their text that they generate is what they're doing is they're making that PRNG, even though they're still using a PRNG for randomness for selecting which word comes next in the sequence. So it's still, the model basically has a list of next words and weights associated with them. It'll then go and deterministically based on the previous, I don't know what the window is, but the previous X number of tokens in the window, it'll use that to see the PRNG that chooses the word, and it doesn't just choose it directly, because then that would get you into the same, the same issue you have where the model can't explore the probabilities and it gets kind of stuck in its own loop, if you will. But it runs sort of a complex, like bracketed competition system between those words. So say, to take our example again, the dog ate my homework and the dog ate my dinner. Let's say those are of equal weight. Then it wouldn't change the quality of the output to choose one of those versus the other based on that PRNG, based on the previous tokens in the system. Again, there is still the problem of controlling for that, AI getting stuck in a loop, but there's ways you can manage that. Or it can bias the probabilities, so it can say, in this specific scenario, we'll still have a random draw, but we'll bias towards, even though the base model says that these words are equal weight, in this very specific scenario with this exact token stream before it, we're going to choose this one with a slightly higher bias. And that over time, you can use that. They use that to basically embed these fingerprintings where it doesn't change the quality of the model generally. Although, again, you could have that edge case where it gets into a loop because you are using something about the current token window to see that PRNG, which is one of the reasons that you want randomness, is to explore the probabilities, even if the AI does start repeating, the same problem statement or something. But you can have a thing where when it repeats the problem statement 3 times in the context window, that's a different PRNG, and therefore you do still get the same, hunting and searching behavior. Anyway, that's a side note. But because AIs are inherently non-deterministic, and you have something that really should be deterministic instructions, like compiling code's always going to be the same. Troubleshooting why you can't compile code, that's different. So if you have, users across different versions of Linux and Windows and Mac OS, you should still be providing the base instructions of like, okay, you need a C++ compiler, and assuming you're using GCC, here's instructions for how you compile this code in GCC. And then if you're on, each of these systems, here's how you install that final built binary in a way that makes sense for the context of the program, right? But I think where AI does make sense is troubleshooting. So if for some reason one of those steps fails, that's there are an unlimited number of reasons why somebody may run into a problem. And of course, the traditional model is you have a troubleshooting guide with a bunch of problems that you can either predict based on your own, experience with, compiling this type of C++ code with these libraries or whatever. And then as, community members have problems with their own unique setups, then you add those to this troubleshooting knowledge base, and slowly over time, it grows to the point where probably most common problems most people face are covered by this guide. But then, some major thing can change, and compilers are the way, a new OS handles binaries or whatever the hell it is, that can invalidate a lot of that old troubleshooting information. Then you're kind of starting over. So I think AI is good in the sense of, you should always have deterministic instructions of, we want this code compiled in this way with these flags to do, and then we want the binary built for, the user's target architecture, and we want to put that here based on the OS so that it's usable. And, if it's a program that requires some configuration, we want to create a config file, or, spin up a blank database that's, started with the right initialization data or whatever in this way. And trying to convert that into natural language and give that to an LLM is just asking for the LLM's, randomness and the difference between different LLMs to just create more problems than it solves. But having deterministic instructions, and then say like a well-crafted AI troubleshooting prompt that says, hey, I'm having, insert the issue you're having here. Here's some context about how the system is supposed to function. Here are the deterministic build instructions that the author recommends. Here's what I tried. Here's the error that I got. And, the important part of that from the developer's perspective would be, here's the important, natural language context about how the program works, how it should be compiled, and ways to check that it is, in fact, working correctly in an automated fashion. and then give that to the user as a prompt they can fill in, their specific error message or something into, feed that to an AI, and then there's a good chance that the AI will be able to go and troubleshoot the problem for the user. But it's not a replacement for, I shouldn't use the word deterministic, because deterministic build is something else, but, clear cut machine, standard instructions that you type into a terminal to build, having like an agentic AI prompt instead of that is kind of silly. Having agentic troubleshooting around that with context that you've thought well about, that's relevant to your specific system, that you give users as a troubleshooting step, that's, I think, a useful tool, and something that, we're not currently doing. Maybe we'll do at some point. Right now, we're just still doing standard instructions for things. But that's where I could see AI being useful in a, installation instructions is not, how do you install it? Ask Claude to install it. The answer is, how do you install it? Here's how you install it. If you're into an issue, here's a crafted prompt that we've written that will give AI some more context about the system that will help you troubleshoot whatever, environment specific issue you yourself are having.
I think this question was actually related to, there's been a bunch of new libraries that have been released that are literally just prompts that you copy paste and it generates a new package in your code.
Oh, so this is even worse. This is like, release version 6 of Photoshop is, Claude, make me a Photoshop. Obviously, it's much more advanced than that, but so it's not even software with build instructions. It's software that the software is prompts for AI to recreate the software in real time.
Yeah, I haven't seen anything that's like entire pieces of software. It's more so being components. So like, if you need, what's a big library, like a JSON encoding library or something, you would use a prompt to generate a part of your code instead of just using already built library.
Yeah, that I mean, for obvious reasons, that's even worse. I think AI for software development, AI is very useful if you know what you're doing, and being careful in how you plan, how you validate the code that it's putting out. The idea that you can just ship prompts that recreate code on demand is, there may be very specific niche use cases where that makes sense. And so I'm not going to say never, never, but for anything that I've ever worked on, I can't imagine a world where that would make sense, because that's like, okay, so you ship software, people are running your software, at least what code they are running if something goes, like, ultimately at the end of the day, what is running on someone's computer are machine instructions that, assuming there's no weird compiler bug, are pretty much an expected mapping of human readable code to machine readable code. And so if someone encounters a problem, you can always go back to, okay, what version of the code are you running? You can go back to the code and you can look at that code and hopefully an error message they sent you and figure out what went wrong. With AI, like prompts as code, it's a fun idea as like they're maybe if you wanted some thing that like the whole point of it is to create different versions of the software for some really weird specific use case, and like that's actually a feature. But for almost all software where you actually want to ship a thing that people use and that behaves in a certain predicted way, I mean, that whole like AI non-determinism that I talked about, that's now amplified by 10, because it's not, somebody whose AI hallucinated a bad install instruction, and that's pretty obvious because it's only a small scope of thing you're asking the AI to do. Now you're saying, I described a system and I sent a million people's AI off to do it independently, and all of them produced a different version of sort of the same thing, but some of them have certain bugs that others don't. And, like that is psychotic, for lack of a better term. It's a fun thought experiment, but yeah, no.
I think it gets worse when you think about security vulnerabilities too, because
for sure,
one model generates a bunch of security vulnerabilities and then you fix those, but another person using the same prompt may have a different set of vulnerabilities or somehow no vulnerabilities.
Yeah,
there's no way of sharing fixes or anything.
I mean, I will say, if you want, if I had to come up with one good thing on the security front, it'd be that assuming you crafted the prompt extremely well, and it was a relatively simple system you were designing, so it didn't need like too much human review, or maybe in future AI models in general didn't need any. You could make the argument that if everyone's running a separate version with separate bugs, that even if there is a bug, it would be limited to that specific person. It wouldn't be like a global bug in the system, but that's a stretch. Short answer, don't do that. Unless it's as a fun experiment, or there's some like very specific case where the idea of having many people running different potentially buggy versions, or re-implementations or alternate implementations of the same code is somehow a feature in some really specific niche, which could exist, but in general, no. That's just horrifying.
We are at the top of the hour. Did you
Okay,
want to
yeah,
show anything off, Max?
we'll do this real quick here. And I do want to caveat before this is a mock-up. Things will change. The purpose of this demo isn't specifically to, if I can even find the right window, it isn't to show off this exact specific design. It's more around where we're going with the overall kind of VE Hemi system rework, what we're thinking about, some different parts of the protocol that are there currently, but they're not really exposed or clear to users, and better ways to visualize better ways to communicate like rewards and kind of schedule those ahead of time in epochs or have them be more predictable. So let me find the window first. Oh wait, you know what? Sorry, I have way too many windows. Let me move this to a different browser and do it as a tab. This will probably be faster. Did that show up? There we go, cool. So again, caveat, this is a mock-up, things are gonna change. And maybe we'll do like a community poll once we have sort of a finalized internal version. If people have, feedback, design ideas, usability ideas, we can get that feedback from the community as well. So if you're familiar with our existing staking page, it has all of the core functionality of you can stake a position, you can see what your rewards are and collect it, obviously pending the next rewards distribution. You can see how much time is left on it. And I think we have the option on the portal right now to extend the lockup time of a position, but there's not really a clear cross-positional view for the user and also for the entire system as a whole to see how you fit into it. It's kind of, all the data is on chain. You could go and look at the total sum of all of the weight of all of the VE Hemi positions at every single point in time, and versus your positions as aggregated to calculate your relative weight over time, but nobody's going to do that and they shouldn't have to. And so part of this redesign is making the overall system easier to understand for users, and then also easier to understand how their blended group of positions that have different sizes and different lockup amounts all kind of collectively orchestrate together into one curve of stake weight over time based on the decay rate of the VE Hemi positions. And then also, it's not really shown clearly here. We're still trying to figure out how to show this because it's, you can do like a logarithmic chart with an overlay, but that's confusing. But how to like line that up with the overall VE Hemi markets, you can see, are your positions on average decaying faster than the rest of the protocol? Because say most people have, 2 and 3 year locks and all yours are 6 month or whatever, and to see how that would cause your yield to decay faster over time or slower over time versus the current projected decay of the overall market, things like that. The current overall VE Hemi, not really market, but staking system. So to just walk through this mock-up real quick. So the top is the sort of global stats and the highlights that are important. And again, these are all mock numbers. This is just for figuring out the visual layout. But how much Hemi staked in the system, for a max lock position, what the APY would be. So if you did a 4-year lock of a position, what APY are you getting? So that's sort of the benchmark or the best number in the system. We're going to, so the VE Hemi contract already has this concept of epoch. So every roughly 6 days, it's not quite 6 days because it's really 365.25 days worth of seconds to account for leap year, divided into 6-day increments that round nicely into it. But point is, roughly every 6 days from the VE Hemi contract under the hood's perspective is an epoch. So we're thinking about framing the reward distribution and other mechanics that need to be sort of quantized. For example, voting snapshots, things like that. Structuring those around the inbuilt epoch system that the Hemi already has, rather than doing it like we've been doing it by 24-hour segments, because it gave more reward granularity, but it didn't really line up with VE Hemi under the hood, and so it doesn't really matter, but there wasn't like a one-to-one clear relationship between epochs, which let you query for specific, weights of certain checkpoints in the overall curve weight calculation of the system, et cetera, et cetera. So total VE Hemi, that's the total stake weight in the system. So basically by dividing those, you get an average lock time so that, if you're locking positions in the ecosystem, you have an idea of, are you sort of above or below the 50 percentile line for, aggregate lockup time weighted by stake weight in the system. Number of stakers, pretty obvious. It's individual EOAs that control at least one active VE Hemi position. Distributed, this would be, total rewards distributed by the VE Hemi reward system. This is experimental. It's just something we threw in there. Eventually, as we talked about in the original Hemi economics hippo, we mentioned the protocol treasury, or like a protocol owned liquidity mechanic, or sort of this evergreen fund where some portion of, it could be chain fees, it could be fees collected from other protocols that we launch in the future that are decentralized, that have their own fee generation system, like, again, Fast Track, HBit VM for 2 different types of operators. Not really decentralized sequencing, because that's really ultimately fees and block subsidies. Chain builder, shared sequencing, shared DA system, the ZK proving marketplace. All of those are additional potential ways for fees to be created by producing a useful product that the use of it itself generates fees that are not directly correlated to transaction fees for just using Hemi in general to do a transaction. So some of those could feed into this sort of evergreen treasury. Governance could direct a portion of that treasury to certain different protocols. So for example, say there's a new DEX that launches, part of what governance could eventually do is vote for, we want to give this protocol some initial Hemi tokens to fund development. And then we want to give them, guaranteed $100,000 of liquidity for the first 3 months. And that can be done collectively through the protocol treasury and, a voting system based around an incentives budget that sort of governance controls. And then in exchange, that project would either contribute an amount of, say, their protocol governance token back to the treasury, or they would agree to do some sort of setup where, and this could be enforced with incentives in certain ways, it depends on the scenario, but where their protocol pays, say, a portion of fees, say it's a DEX or a lending protocol or something, a portion of fees that their system collects back to the treasury. So it's sort of this, decentralized protocol growth engine that can do things like provision liquidity and provision incentives in ways that should eventually feed back into the treasury. And then some amount of yield on that treasury could go, if voted for by governance, out to VE Hemi holders. That's an idea. It's still in the planning phase. It's something that we've talked about wanting to do for a while, but we're still figuring out the right design, because you don't just want to give decentralized governance, carte blanche control over a token treasury, because it basically just devolves into a bribing contest where somebody bribes all the voters to let them steal the funds. And so you got to be very careful how you design that system, but designed properly, it's an interesting mechanic. And then going down on the page, so total amount of Hemi this is your personal dashboard piece of it. And again, we'll probably differentiate it visually a little more from the the top of this to make it clear this is, global metrics, this is your metrics, but you get the overall point. So this would be obviously how much actual Hemi tokens you have in positions that will be withdrawable when they mature, the voting power that those positions collectively give you, rewards that you have left to claim that you haven't claimed yet, and the next position that unlocks. And if it's not one that's already unlocked, it would show a countdown for that. And then this is, I think, an important mechanic because it's hard to visualize, especially if you have multiple VE Hemi positions, how those positions, work together and what that means for your participation in the system from a reward sharing and governance voting weight perspective over time. So this basically sums up all of your positions together and then shows you, as a time series chart, it shows you left to right. Here you are today, and you have, 76,000 VE Hemi worth of voting weight in the system. And again, we're trying to figure out how to best overlay the global curve as well onto this without making it super confusing with like a logarithmic scale or something. Because then you wouldn't. There's things we can do that give you the correct data, but they're hard to understand, and so we're trying to find a middle balance there. But just looking at this from a purely individual perspective, this would show you, okay, you can see I'm currently at this, over the next year, here's how my collective positions will decay. Here's the next unlock of one of my positions, so that marks naturally a sort of inflection point in the graph. And so you can line that up with an upcoming unlock of, say, this is the 120K Hemi unlock, so that's this position 4211, which has 120K, and you can see what the multiplier is of that. And so this gives you sort of a time series, 4-year out view of all of your positions, how they add together, how that's going to decay in weight over time. Obviously, you can change that by extending positions, increasing amounts, whatever. But this shows you your current status of your all of your stake positions. And then obviously the position panel, this is basically what we have now, but a little bit richer data and easier to interact with to increase it, extend it. And then also, since we're spinning up governance in the near future, an easy way to interact with the delegation system on a per position basis. Because as a reminder, Aragon, the system we're using, we built this sort of adapter glue between VE Hemi and the way Aragon expects a voting token to work, because there were some things with VE Hemi with the, using NFTs for the positions and having delegation on a per position rather than per, account to account mapping. So there was some like glue in between that we needed to build to make that the VE Hemi system compatible with Aragon voting. And so the end result of that is the Aragon UI lets you do macro things like, delegating all of your positions, because it understands this EOA to EOA delegation concept. But since the Aragon UI is not familiar with position, single position delegation, more granular features like that would be also exposed through this new VE Hemi staking dashboard. So anyway, that's the high level. Again, work in progress. It's a mock-up. We're playing with ideas, but just sort of figured I'd give people a preview of what we're thinking here. And once we have sort of a more concrete, V1 nailed down with the features that we want now. So, pretty much everything here except the protocol and liquidity treasury, that has to be planned out more from a, game theory and incentives perspective. But just improving the mechanics of VE Hemi, improving visibility of what's going on in the system, how your positions interact with that, how your positions change over time, and then easy controls to, if you want to change any of that by extending lockups, adding amounts, you want to do granular per position delegation for governance purposes, or you just want an easier way to visualize all of your positions together and what that means for, current rewards, future projected rewards, being able to show that all in one easy to understand dashboard instead of you having to go and figure out all of this from on-chain data, which realistically nobody is going to do or should have to do. So anyway, that's the demo.
Right. That was awesome. Let's see. Oh, yeah, we are 15 past, so we got to wrap things up. Well, thank you everyone for tuning in to another Midweek with Max. Just a reminder, there is a Rumble session in the Hair server, and they're also having some sort of a governance vote. For more clarity on that, pop into the Here Discord server and talk to Alex or any of the admins in there. In addition, join us tomorrow at 11 a.m. Eastern Standard Time for Protocol Engineering office hours, where we can answer your technical and building questions. That's it for me. So let me turn it over to the team. And by the team, I mean Max. And for any outros, and we'll see you soon.
The limited team that we have today. Yeah, so appreciate everyone joining us. We did run a little over, but hopefully it was worth it for the Hemi demo. And yeah, appreciate everyone joining us. We do have engineering office hours tomorrow at the same time as Midweek with Max. So same time, just Wednesday instead of Tuesday. So if you're building anything, you have any building questions, you're getting ready for the next Hemi Arcade and you have some gaming specific questions, whatever it is, if it's related to building on Hemi, we are happy to chat through what you're working on, answer any questions, help think through design ideas, things like that. And beyond that, yeah, stay tuned for some of these VE Hemi sort of usability improvements and the new payout or updated rewards distribution coming soon. Also, keep your eyes peeled. We will, in the next couple of weeks, be releasing some version of the ZK Miner for people to play around with and the ZK Marketplace. That'll be through the beta testers channel. So if you want to participate in that, give feedback, earn some tokens for doing so, stay tuned for that. And yeah, I think with that, we've gone over enough. So we will see everyone either tomorrow at office hours or next week on Midweek with Max. Or I think we have one other live stream thing this week too that Jeremy's doing. I don't see it on my calendar. I'm not sure if
I also do not have it on the calendar, but I believe there is another Built on Hemi series coming up. We can get clarity and put an announcement about that as soon as Jared gets back.
All right, perfect. I appreciate everyone coming out, and we will see you soon.
All right.